In 2012, a single missing semicolon in a trading algorithm cost Knight Capital over $440 million in just 45 minutes. That tiny dot almost broke the Wall Street.
So, what is programming and why does it even matter that much?
According to Wikipedia, computer programming or coding is a composition of sequences of instructions called programs that computers can follow to perform tasks. Suppose you put coin in the vending machine and you get your desired snack from it. Asking the robot to make me a coffee wouldn't work. Rather, using a function like brew coffee, which is already embedded function in the robot, would work. So you may ask, what are programs? Programs are step-by-step instructions that are given to the computer by a programmer or a developer.
C, C++, Java, Python are some popular programming languages, and they differ by levels. Low level and high level. It sounds like a game ranking system, right? Well, no. Actually, they differ by how close they are to the machine code. More about that later. Despite having numerous number of programming languages, there is only one universal language, which is binary, filled with ones and zeros. You see, despite being low level or high level languages, or either being compiled or interpreted, they ultimately lead to the machine code or the binary code, filled with ones and zeros. Wait a minute, how do computers even understand binary in the first place? Well, at the most basic level, it's just electricity. Either it flows or it doesn't. 1 is equal to on, 0 is equal to off. And this is the concept of binary. These tiny on or off signals pass through circuits, then gates, and then flip-flops, storing ones and zeros like tiny memory switches. And if you zoom in, like really zoom in, really zoom in, you'll find billions of these switches packed into a chip of size of your fingernail. This is where the human brilliance shines. Nanotechnology is so advanced, it packs tens of billions of transistors into GPUs, doing millions of calculations in just a blink. So yeah, binary might look simple, but what powers it is the engineering magic at the atomic level. Every time you send a message, scroll past a meme, or watch a video, you're seeing something magical. It's not really magic, it's just binary, ones and zeros. Take text messages for example. Every letter you type, it's converted into a number using something called as ASCII, the American Standard Code for Information Exchange. For example, capital A is 65, small a is 97, and your entire text, it's just a string of numbers. And images? They're just grids of pixels, and each pixel is a combination of red, green, and blue values, also known as RGB values, and each of them are encoded in binary. Videos? Think of them as thousands of images, called frames, shown rapidly like 30 or 60 per second, which is also known as FPS. To make them playable, they're compressed using codecs like H.264. Each second of that video has a certain bitrate, meaning how many bits are streamed per second. So whether it's a voice note, a meme, or even a full HD movie, your device is constantly decoding billions of ones and zeros, turning them into what you see. In the digital age, everything is binary, the language of electricity, logic, and pure computation. Alright, next big question. Which programming language should you use? The short answer, what are you building? That's it. Web, APIs, JavaScript or TypeScript. Data and AI, Python all day. Mobile, Kotlin for Java, Swift for iOS. Games and high performance, C++ or C# for sure. Systems or kernels, C, maybe even Rust. Are you just testing ideas? Pop open Replit.com or any other online compilers. Link below is a VS Code downloader. Add the Python and the JS extension, and you're going to code like a dev now.
Pick the right language, double check those semicolons, and smash that subscribe and share button so nobody loses a $440 million trade deal.